Good afternoon, Davao de Oro. Good afternoon, TV Eskwela viewers and listeners, especially to all grade 8 students who are watching right now. I am your teacher, Stieven Shegal and Plaza from Monte Vista National High School, Monte Vista District. We are here, happy to serve you for bringing fun and exciting lessons in grade 8 science. So we hope you had already prepared your pens, record notebooks, and modules. And be sure that you already had your lunch as we go through our discussion. So are you ready for today's lesson? That's good! Let's have first our pretest in page 2 in your module. Directions. Choose the letter of the correct answer. Write your answers on a separate sheet of paper. Number 1. Who formulated the 3 laws of motion? Letter A, Aristotle. Letter B, Isaac Newton. Letter C, Thomas Edison. Letter D, Alexander Graham Bell. If you answer letter B, you are correct, Isaac Newton. Number 2, which has more mass? A kilogram of cotton or a kilogram of iron? Letter A, the iron. Letter B, the cotton. Letter C, they both have the same mass. Letter D cannot be determined from the given information. If you answer letter C, you are correct. They both have the same mass. Number 3, which has the greatest inertia? Letter A, airplane. Letter B, car. Letter C, jeepney. And letter D, bike. If you answer letter A, you are correct, airplane. Number 4, which of these vehicles moving at the same velocity is difficult to stop? Letter A, a bus. Letter B, a car. And letter C, a train. Letter D, a truck. If you answer letter C, you are correct, a train. Lastly, number 5. All of the following apply the third law of motion except letter A, kicking a ball. Letter B, rowing a banca. Letter C, throwing a stone. And letter D, taking out ketchup from a bottle. If you answer letter A, you are correct, kicking a ball. Now, before we introduce to you our topic this afternoon, let us now have a short review of the previous lesson, which is about force. We know that force refers to the push or to the pull. Force also can make any object move faster, stop, or change its direction of motion. You even describe force by familiarizing some terms. The following are magnitude, direction, point of application, and line of action. You also read and identify the types of force, namely contact force and non-contact force. Contact force is a type of force where objects touch or contact with each other. Some examples of contact forces are applied, friction, normal, and tension. While non-contact force is a type of force where objects do not touch or contact with each other. These forces act on over an area called field. Gravitational and magnetic force are some examples of non-contact force. Moreover, you even discovered the difference between balance and unbalanced force. Again, what is balanced force? Very good! Forces that are equal in magnitude but opposite in direction are called balanced forces. Balanced forces do not cause a change in motion. When balanced forces act on an object, the object will not move. Unbalanced forces are not equal and in opposite direction. Okay, students, did you understand the concepts of force? That's good. Now, we are done with the review and we can now proceed to our new lesson. What do you think would be our lesson for today? That's correct. This time, we will discuss with you the 3 laws of motion. We hope that you will be able to achieve our objective for today. What would be our objective? At the end of this session, you will be able to understand that when a body exerts a force on another, an equal amount of force is exerted back on it. So are you now ready to listen? Fabulous! We will discuss this time the Newton's 3 laws of motion. But before that, let us acknowledge first the man behind these laws. Do you know who this man is? Yes, you are correct. His name is Sir Isaac Newton. Sir Isaac Newton formulated the 3 laws of motion. Are you familiar with the 3 laws of motion? Let's discuss the 3 one by one. Newton's first law of motion is commonly called as the law of inertia. The law of inertia states that an object at rest will remain at rest and an object in motion will continue to move at constant velocity or constant speed in a straight line, unless acted upon by unbalanced force. To understand the Newton's first law of motion, we need to know first the inertia. Let's have an example. Consider yourselves when you are riding on a bus. Initially, the car is at rest. When it starts to move, what will happen to you when the car starts to move? Oh, your body has a tendency to move backward. On the other hand, when the car suddenly stops, your body has the tendency also to move forward. More so, when the car either starts to move or suddenly stops, your body has the tendency to change your state of motion. Your body's response on objects at rest and objects in motion, like the bus, shows the property of inertia. Inertia is the tendency of an object to maintain its state of rest or of uniform velocity in a straight line. The mass on an object measures the inertia of an object. The greater the mass of an object, the greater the inertia. The greater the mass of an object, the greater the inertia, and the harder it is to move when it is at rest, or difficult to stop when in motion. Are you learning now about inertia? Very good! This time, let's check your ideas. Which has more inertia? A phone or a television? Again, which has more inertia? A phone or a television? Wow! Fabulous! It is the television because it has a greater mass. Now, let's proceed to Newton's second law of motion, which is commonly known as the law of acceleration. As we all know from the first law, to overcome inertia of an object, we need to apply unbalanced force. Newton's second law explains how fast the object will move. Well, the law of acceleration states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these 2 swings. If you apply the same force on both swings, which do you think will move or accelerate faster? Yes, you're very right. Let's first push a little kid. See, it goes very high. Now, push this fat man with the same force. See, it does not go further because it has more mass than a little kid. So, the more mass there is, the force required to push an object is also greater. Now, let's look at the mathematical formula of the second law of motion again. The equation can be stated in three forms. First, if you were to find the summation F, you need to multiply the mass by its acceleration. Again, in finding the force, just multiply the mass and the object's acceleration, or summation of F is equal to mass times acceleration. Can you write it there? Very good. Next is finding the mass. You need to solve the problem by dividing the force by its acceleration, or m is equal to force over acceleration. More so, in calculating the acceleration, a solution would be a force divided by its mass, or A is equal to force over mass. Did you follow or capture conversion? Wow! Amazing! Now, in page 10 to 11 of your module, examine and understand the problems given in your module. In problem 1, it shows how to find the force, while in problem 2, it shows how to solve the acceleration. More so, in problem 3, it shows how to calculate the mass. So let's try to solve problem number 1. The problem goes like this. A 1,000 kilogram truck is traveling at an acceleration of 4,500 meters per square second east. Find the net force needed to accelerate the truck. First, look for the given presented in the problem. The givens are the following. A is equal to 4,500 meters per square second east, and m is equal to 1,000 kilograms. Now, what is missing is the summation force. Then, go for the solution. Since we are going to find the summation force, the formula in calculating the force is summation force is equal to m times A. Then, substitute all the givens to the formula. Summation force is equal to 1,000 kilogram multiplied to 4,500 meter per square second is equal to 4,500 kilogram meter per square second, or 4,500 Newton easts. Okay, students, did you get it? Okay, students, now it's your time to shine. Can you try to solve this problem? An object with a mass of 4 kg accelerates at 4 meters per square second when an unknown force is applied to it. What is the amount of force? Okay, what's the answer? Do we have the same answer? Great! The answer is 16 kilogram meter per square second, or 16 Newton. Wow! It shows you understand the lessons well. And now, let us continue to Newton's third law of motion. Let's look to this example. Why a cannon moves forward when it shoots its cannonball. This sample applied the Newton's third law of motion. The third law of motion is the law of interaction, which states that for every action, there is always an equal and opposite reaction. This law tells us that the force exerted on any object is always exerted back by an equal magnitude of force, but in opposite direction. Always remember that in this law, forces always come in pairs. These are called action and reaction forces, and they do not act on the same body. In determining the action and reaction forces, you should be able to identify first the action that requires force, and then identify the reaction force that counteracts the action force. An example of this is dropping a basketball ball. As the ball hits the floor, it causes a downward force on the floor. This is the action. Then, the floor reacts by pushing of the same force but in opposite direction. And this is now the reaction. Another example of this is a boy pushing a wall. When the boy pushes the wall exerts an equal and opposite magnitude of force to the boy. Now think of another example which could be applicable to the third law of motion. Good job, learners! We are done with the discussion on the Newton's three laws of motion. So, can we recall the three laws of motion? Yes! The first law of motion is the law of inertia, which states that an object at rest will remain at rest and an object in motion will continue to move at constant velocity or constant speed in a straight line unless acted upon by a net force. The second law is the law of acceleration, which states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is the same as the direction of the net force acting on the object. And the third one is the law of interaction, which also states, for every action, there is always an equal and opposite reaction. That's all for today, grade 8 learners. We are finally done with our discussion. So, I guess you are ready now to take the quiz. You can continue answering your assessment in your module on page 18 to 19. Again, we hope that you were able to infer knowledge on about the concepts of the three laws of motion. Also, we hope that you were able to understand that when a body exerts a force on another, an equal amount of force is exerted back on it. Once again, thank you so much for listening and see you on next session through TV-based instruction. Again, I am your teacher, Stieven Shegal M. Plaza from Monte Vista National High School, Monte Vista District, saying, dito sa PV Eskwela, sa pag-aaral, sama-sama. Bye-bye!